I'm going to go over a few problems from the worksheet on this video 7, 16, and 20. Just trying to hit certain things that I know are going to be covered on the test that look kind of like it. So just to help you out. So let's do number 7. Number 7 is y equals x squared plus x over negative 2x squared minus 2x plus 12. So we're going to start with horizontal asymptote. The degrees are equal because they're both x squared. And I'm going to go with a over b. The leading coefficients are 1 over negative 2. Those are the leading coefficients. So y equals negative 1/2 is the horizontal asymptote. Get rid of those. The y-intercept is the constants. Now there's no constant here. There's a missing one. So that's 0. So really my constants are 0 over 12, which 0 divided by 12 is 0. So 0 comma 0. Now we need to factor this. I'm going to take a GCF of x out. I'm going to take a negative 2 out. And when I take negative 2 out, I'm left with x squared plus x minus 6, which factors into x plus 3 and x minus 2. So those are my factors. No factors are shared, so there's no hole. The zeros in the denominator, negative 3 and positive 2, and the numerator 0 and negative 1. So my vertical asymptotes come from the zeros in the denominator that are not shared, and that's negative 3 and 2. The x-intercept comes from the numerator, which 0, 0, I already had that actually up here, so I need to write it again, and negative 1 comma 0. So as I graph this, what I have is at negative 1, at negative 1/2 is a horizontal asymptote. And then at 2 is a vertical, and at negative 3 is a vertical. And then I just need to fill these in. I have a point at 0 comma 0 and at negative 1 comma 0. So I just need to get some more points. I'm going to use negative 4. I'm going to use negative 6. I'm going to use negative 2, 1, 3, and 5. They're all good ones, but you can vary from that slightly. So as I plug all those into the calculator, to the graph app, what we see is that I would get points down here. And it would follow this asymptote here, and then this asymptote. But get those points. Figure out what those points are using the table app on the calculator. And then here, it's going to come down here, hit these 2 points, come over and come up here following these asymptotes. And then again here, it's going to follow these 2 asymptotes. But you need to go ahead and get those points, plug those into the table app, and you plug the original in. Plug that in, and just get a bunch of XY points for negative 6, negative 4, negative 2, positive 1, 3, and 5 would be good ones. That way I have 2 in this section here, 2 in this section here, and then a couple other points to see what it's doing in the middle besides these 2 x-intercepts. Okay? So that's 7. Let's do 16. Number 16 is y equals x squared plus 3x over negative 4x plus 4. So, horizontal asymptote, there is none, because the numerator has a bigger degree than the denominator. This is x squared, this is just x to the first. Okay? So I'm going to do my oblique. So I'm going to take long division, negative 4x plus 4, and I'm going to divide that into x squared plus 3x. And really there's a 0, but we won't use it. So 1 divided by negative 4 is negative 1/4 x. And I multiply it back through. Negative 1/4 times negative 4 is positive 1. Negative 1/4 times positive 4 is a negative 1x. And then I subtract. So when I subtract, it would be 3 minus a negative 1, or 3 plus 1, making 4x. Now when I divide, 4x divided by negative 4, that's negative 1. So my oblique asymptote, y equals negative 1/4 x minus 1. All right, let's go y-intercept. Again, my y-intercept, I have an unseen 0 here, so it's 0 over 4, which is just 0, comma 0. The vertical asymptote, let's factor this. This is my original, and I'm going to factor it by taking an x out of the numerator and a negative 4 out of the denominator, making it x minus 1 when I take negative 4 out. So there's only one 0 in the denominator, and it's 1. So that's the vertical asymptote. In the numerator, I have
Bryson Powell, please come to the office. Bryson Powell, please come to the office.
3. So those numerator zeros are my x-intercept. 0, comma 0, which again I already had, and negative 3, comma 0. So what this graph is going to look like is from negative 1, I'm going to go down 1 over 4. And I can go up 1 and back 4 as well. So that makes my oblique asymptote. I have an intercept of 0, 0, and another one at negative 3, but my vertical is at 1, x equals 1. So it's going to come along this asymptote, hit this point, come up and follow this asymptote, which means it's probably down here. But I just need some points, like 2, 3, and 4 to see where it falls. And I'd say negative 1 to see where it hits down here would be a good point as well. Okay, on to 20. Number 20, I have y equals x squared plus 7x plus 12 over negative 4x squared minus 8x plus 12. Okay, so the degrees are equal. So the horizontal asymptote uses a over b. That's 1 over negative 4. So y equals negative 1/4. That comes from the leading coefficients because these two degrees are equal. All right, so now what about the y-intercept? The y-intercept comes from the constants. 12 over 12. 12 divided by 12 is 1. So x is 0, y equals 1. Vertical asymptote. All right, we got a factor cancel here. The numerator factors into x plus 3 and x plus 4. The denominator, I take out a negative 4 first. It gives me x squared plus 2x minus 3. So what I have is negative 4, and I have x plus 3 and x minus 1. So I do see a shared 0. I get negative 3, positive 1, that's a 0. Up here I get negative 3 and negative 4. So there is a shared one here. So the one that's not shared, which is 1, x equals 1 is the vertical asymptote. The one that is shared is the whole, and that's at negative 3 comma something. The remaining numerator gives me my x-intercept, and that's at negative 4 comma 0. Now I do need to get the y value of the whole. So when I take this and reduce this equation, the x plus 3's cancel, leaving x plus 4 over negative 4 times x minus 1. When I plug negative 3 in, negative 3 plus 4 is 1. Negative 4 times negative 3 minus 1 is negative 4. What I'm getting is 1 over 16. So at 1/16 is my whole. So I'm going to go ahead and graph that. I have a horizontal asymptote at negative 1/4. So here's negative 1 at negative 1/4. I have a vertical asymptote at 1, x equals 1. I have a hole at negative 3 comma 1/16, just barely above the axis. I have an x-intercept at negative 4. So here's negative 4, and there's my x-intercept. I have a y-intercept at 1. I have 3 points in this section already. It's going to go from this point, skip over the hole, to this point. So it's going to come up and follow this vertical. It's going to come down and follow this horizontal, even though I'm a little killywampus here. Which means the other side's probably going to be down here. So you just need some points, like 2, 3, 4 to help fill that. Okay? Hopefully those 3 help, kind of hit a little bit of everything.